So students, in the last class we have studied about the differential, how to calculate the solution for the differential equation of a distributed system. Now let us look into the first case, that is simply supported beam. So this is a simply supported beam. So this from here only, this solution only we will be starting the how to solve it. Now here we know that a beam, for a beam simply supported beam, the boundary condition at x is equal to 0. Here the what will be the deflection? Deflection will be 0, moment is also 0. Then at x is equal to L, this point, here the deflection is 0 and moment is also 0. So here the deflection is represented as y. Instead of y we are having phi of x, and the moment is phi square d square phi by dx square, d square phi by dx square. So these are the two boundary conditions we are having. Two means in both the cases, at here we are having two, at one end we are having two boundary condition, here also we are having two boundary condition. Now we know that this is a solution. Phi of x is equal to c1 cos hx into lambda x plus c2 sin hx into lambda x plus c3 cos lambda x plus c4 sin lambda x. Here both are having h, they are h functions, here they are normal functions, normal angles. Now applying the boundary condition, first boundary condition, at x is equal to 0, phi of x is equal to 0. So phi of x is equal to 0. At x is equal to 0, what is cos 0? Cos 0 is 1. So c1 into 1 plus c2 into 0 plus this term, this will be 0. Now here it will be also 1. This will be again 0. Therefore c1 plus c3 is equal to 0. Now at x is equal to L, again we are having another equation. At x is equal to L, c1 cos hxl plus c2 sin hxl plus c3 cos lambda L is equal to, that is, let it be equation number 2. Now we are having two more boundary conditions, that is dou square phi by dou x square. So first of all we are finding what is dou phi by dou x, dou phi x by dou x. So I am just substituting these terms, I am differentiating, I will be getting, then again from that one more differential is taken, so I will be getting like this, that is dou square phi x by dou x square is equal to c1 lambda square cos h lambda x plus c2 lambda square. Like that I am getting a long equation. Now I am going to apply. At x is equal to 0, dou square d square dou phi x by dou dx square is equal to 0. So here again this term will be 1, this sin 0 is 0, like that I will be getting c1 lambda square minus c3 lambda square is equal to 0. From here I can take lambda square constant. Lambda square, it cannot be 0. Therefore c1 minus c3 is equal to 0, or c1 is equal to c3. Okay, I can write, this is my first equation, c1 is equal to c3. I got it, c1 is equal to c3. Now again I am applying the so here I am having the next boundary condition. At x is equal to L, again dou square phi by dou x square is equal to 0. So from that I will be getting so substituting again, here you can see, here I can substitute, instead of c1 I am substituting c3. So I will be getting 2c3 is equal to 0, or that is substituting 3 in equation 1. So this is equation number 3. Okay, this is equation number 3, and this is the term which I got it. This is the fourth one. Now I am substituting 3 in 1. What is 3? 3 I am having, this is my equation 3, and 1, what is equation number 1? c1 plus c3 is equal to 0. So I have got 2c3 is equal to 0, or c3 is equal to 0 and c1 is equal to 0. So two terms I have neglected. Now equation 2 and 4, I am adding equation 2 plus 4. What is equation 2? Equation 2 is this, where is equation number 2? This is equation number 2, and equation number 4 is this one. So I am just adding it. So adding it, I will be getting 2c1 cos hx lambda L plus 2c2 sin hx lambda L is equal to 0. But what is c1? c1 is 0. Now I am having c2. Now here you can see 2c2 sin hxl is equal to 0, or from this c sin h into lambda L, it cannot be 0, only c2 can be 0. Therefore c1, c3 and c2, these three terms are 0. Now I am having now equation 2 minus 4. This is equation 2 plus 4, now 2 minus 4. So C3 is 0, then I am having this one C4 sin lambda L is equal to 0. But in this you need to understand is that here C4 can never be 0 because all other terms have become 0. So only term that can become 0 is sin lambda L can be 0. But sin lambda L 0 means when is sin theta 0? When it is 0, pi, 2 pi, 3 pi. So from this I can write, therefore lambda L is equal to, it can be 0, pi, 2 pi, 3 pi. So lambda is equal to n pi by L. N pi by L. N can be 0, 1, 2, 3 like that. So we got lambda. But we know that lambda raised to 4 is equal to m into omega square by EI. This is a term which we read in the first part of the class. So here n pi by, but lambda we got n pi by L. So n pi by L raised to 4 is equal to m into omega square divided by EI. From that, omega is the frequency. So I can take omega is equal to n square pi square by L square into root of E by m. So here, that is omega is equal to, the natural frequency is equal to, this is equation of natural frequency, is equal to n square pi square by L square into root of EI by m. Now when n is equal to 1, what will be the natural frequency? First natural frequency will be pi square L by root of E by em. When n is equal to 2, it will be n square, so it will be 2 into 2, 4 pi square L, then 9. So like that I can find out each of the natural frequencies. So that is the term it is written here. You can see natural frequency. So this is the natural frequency. Omega is equal to n square pi square by L square root of E by m. So this is the natural frequencies. Okay. Now we have to find out the mode shapes. How the mode shape will be. So now we have phi x is equal to, from this term C1 is C1 0, C2 0 and C3 is also 0. Only term is C4 sin lambda x. So phi of x is equal to C4 sin lambda x. What is lambda? N pi by L. So phi of x is equal to C4 sin n pi by L. Now let us take the first mode shape. You can see one mode shape. That is when n is equal to 1, phi is equal to C4 sin lambda. Instead of n I can write a pi x by L. N is equal to 1. So at x is equal to 0, phi of x is equal to C4 sin lambda, that is equal to 0. At x is equal to L, again it is 0. So in the both the ends it is 0. Therefore this will be my first mode shape. Okay. Now by seeing the next 3 mode shape, you will be understanding why it is written like this. When second mode shape n is equal to 2, that is here another small in the note, the C2 is written, this is C4 only. Okay, that you need to understand. Here instead of the C2 it is C4 only. So when n is equal to 2, phi of 2 is equal to sin 2 pi x by L. At x is equal to 0, phi of is equal to 0. At x is equal to L, it is 0. Then at x is equal to L by 2, again that is also 0. Sin pi, it is 0. Therefore the second mode shape will be like this. That is at x is equal to L by 2. Now I am considering the third mode shape. At x is equal to 0, it is 0. At x is equal to L, here it is written 3 0. 3 0 means third mode shape, in that is 0. This is third mode shape at x L. Now when it is coming into x is equal to L by 3, it is also 0. Therefore this will be our third mode shape. Now the fourth mode shape will be like this. So what happened in the fourth mode shape? At x is equal to 0, it is 0. At x is equal to L, again phi of x is equal to 0. At x is equal to L by 4, again 0. At x is equal to L by 2, again how it is coming? That is sin pi is equal to 0. Sin 2 pi, it is again 0. That is sin 180 and sin 360, everything will be 0. So likewise I can find out the mode shapes. Okay. So where we have started this? We started this from this equation. So if you are knowing this equation, from this you can just write and find out. First one you have to find out what is the natural frequency. So this is the natural frequency. These are the natural frequencies of different modes, and these are the mode shapes. Okay. So only by writing only you will be able to understand what is been written. Compared to some of the topics in third and fourth module, this is very easy because we have just need to find out the solutions by substituting the standard equation.